Good morning, guys. So today we are going to solve removing digits. So you are given an integer n. On each step, you may subtract one of the digits from the number. How many steps are required to make the number equal to 0? So we are given a number n and we have to make it 0. And the n is between 1 to 10 in power 6. So let's start. So what we have given here is we have given a number n. What we can do, we can subtract any digit. Suppose the number is 27. So we can subtract 2 or 7. So if we subtract 7, it will be 20. Now we can subtract 2 or 0. If we subtract 2, it will be 18. Now we can subtract 1 or 18. If we take 8, it will be 10. Now if we take 1, it will be 9. And now if we take 9, it will be 0. So how many steps it require? 1, 2, 3, 4, 5. 5 steps. So we have to find what is the minimum number, what are the minimum number of steps. Okay. So how we can do it? Suppose at every step we have a choice to choose a digit. Like from 27, if we chose 2, it would be 25. And if we choose 7, it would be 20. From 20, we have only one choice, that is 18. Because if we choose 0, it would be same. Here we have two choices, 2 again, that would be 23. And here also 5, then 20. So this way we can form a tree. Here also 17 and 10. From here only one choice, 9. And from 9, 0. So this way we can make the whole tree. But you can see that once, suppose we have calculated the answer of 20. Okay, so when we require 20 next time, we won't have to calculate it again. That is what we call memoization. So we can solve it by what would require to solve it. We just require the number n. Let's say solve of n. Now, as I said, we would check for every digit what would be the answer. So if n equal to 0, then we have reached our destination. So we would simply return 0. Okay. Now for every integer n. So first we will take a temporary number. Now we can also convert this n into string, and we can take consider every string. We can consider every character of the string, and we can also perform this operation. But here I have chosen to stick with int. It's because int requires a little bit less space than the string, because each string will require 4 characters, 4 bit for a single character. So if a number is 1 also, then also it will take 4 bits. And with this, we can do it with only 1 bit. A little bit of optimization. Uh, so now I hope you guys know how to extract every digit from a number. So what we will do, modulo 10 to extract the last digit, divide 10 by 10. So it will give us the last digit. Okay, so now we will simply subtract that, and we will define our answer here. What would be our answer? We will take it as int max because we require the minimum. So answer equal to minimum of answer and solve n minus digit plus 1. N minus digit plus 1. So this would be our answer. Now at last return answer. So this is what we have done so far. We would, if the n is 0, we simply return 0. Now for every digit in n, we would subtract that digit and return the answer plus 1. That is, if we take digit 2, then whatever would be the answer n minus 2, whatever would be the answer of n minus 2 plus 1, because we have taken the 2 as answer. Now to memorize, we can define a DP because as I told earlier, where if we simply run this code, it will give TLE because it will calculate every time. So for 27, it will calculate 25, 23, 21, 20, and so on. But when it would again require 20, it will again calculate everything. So it will basically go exponentially. So this code won't work. But if we memorize means we are simply uh, uh, storing the data which we have already calculated. Suppose if we have calculated for 20, then we would store the answer of 20. And when we again require 20, we would return that. So simply we can put here if already found. So if we are working with a array or a DP, let's say we have a global DP, and if that is -1, if DP of n is not -1, because initially everyone was -1, and if we have found that, then we will not calculate it again, and so we will simply return DP of n. And at last, whenever we are returning, we will also store it in the answer DP of n. Then only we will return. So for next time, it will help us. Now we can. This was the recursive approach. We can also do it iteratively. The process is same. First, what we required, we are always going in decreasing order. Like from 27, we would go to 25 to 20. Similarly, so what we can do, we can go in increasing approach. Now the same thing which we have done earlier. This the same code. Span equal to sorry. DP of n would be minimum of DP of n comma DP of n minus digit plus 1. Now this would already have been calculated. So that is how we can find it, and we will return dp of n. Our base case would be dp of 0 equal to 0. The time complexity for this would be, we would be iterating to every number, so that would be O of n into the digit. Now it is, sorry, so into digit. So the maximum digits any number can have is already given 10 to the power 6. So it would be 6 only, the maximum digits. So it is O of n into 6, which would be nearly around 6, or we can also consider 7. Then also it would be 7 into 10k power 6. So it is still less than 10 power 8. So it would run. Okay, so let's code. Let us do a dry run for simply, let's say, 8, 18. So how that would work if we go for the recursive approach, it would be 17 or 10. From here it would be 16 or 10. From here it would be 15 or 10, 14, 13, 12, 11, then 10, then 9, then 0. Here whatever it would be 10. And from 10 it would be 9 and 0. So we already know what would be the count here, 1, 2, 3. The answer would be 3. Okay, so let's code. We are given an identity. Initially everything would be like, and dp of 0 would be 0. dp of I will give us minimum steps to reach I. Return dp of I. So you will start from 1 till n. Then extract the digit dp of I equals to minimum of dp of I, comma dp of I minus digit plus 1. Of dp. Mm, wait, we have put on the int I equal to max. So whenever it was doing +1, it was because of the overflow, it was converting it to minus infinity. So it was showing that. Now we can see our answer is 5. Here also 5. Let us try to submit it. So as you can see, it got accepted. Thank you guys. See you in the next one.